this video, we will discuss the problem number of turns in a binary tree. The problem says that we'll be given a binary tree and we'll be given data value of two of its node. So we'll be given the data value of two of its node and we have to find the number of turns we need to take to reach from one node to another node in the given binary tree. So let us quickly discuss this using the sample test case that has been given. So I'll quickly draw the sample test case to discuss further about this problem. So let's say if we have been given this particular tree here. So let's say our tree is like 1. First of all, we have 1. 1 is connected to 2, then 3. After that, 2 is connected to 4 and 5. And then 4 is connected to 8 on the left. After that, after 3, like 3 is connected to 6. 3 is connected to 7 as well. And 6 is connected to 9. And 6 is connected to 10 as well. Okay, if these are the connections that we have, let me check. So we have 1 2, then 1, then 2, then 4 5 6. After that we have 6 7, and we have 8 9 10. Okay, so suppose that the first node given to us is, let's say, this node 5. Okay, and the second node that is given to us is this node 10. Okay, so you can observe one more thing in this particular problem, that basically you need to find that the number of turns that you need to take from one node to another node. So what are the number of turns? See, if you're starting, so let's say if you see, so you have to reach 5, and like from 5 you have to reach 10, suppose. So first of all you'll go to the left, right? So currently you are not taking any turn, because if you have just started, and suppose you start from the left. Okay, so if you start, like if you start directly from here, so you have not taken any turn, so your motion will be in this direction. You will be trying to move in the left direction only, correct? When you move in other direction, when you move in the right direction, then you will take a turn. So currently, suppose you started to move in the left direction, so you'll not count it as a turn. Then what happens? If you see, you will move in the right direction, correct? So this will be counted as one turn. Okay, so basically one turn is counted here, right? After this part, what will happen? From here you can see that again you will be taking a turn downwards, correct? From 1 you will be taking a turn, right? You can see, because your motion was in this direction, but your motion now is in this direction. So basically your turn like you have changed the direction, right? You were moving in this direction, but you have changed in this direction. So that means you have taken one more turn. So for this path also you will add one more turn. So one more gets added to the answer. After that, if you see, so actually you were going in this direction, right? You were going in this rightward direction. But if you will observe, to reach 7, you have to take the path and you have to move in the left side. Okay, so you have to move in the left side. So that means one more turn you will take on this path, correct? After that, if you see, so if you're moving in this direction, leftward direction, so you should move in this direction, right? Basically in this direction. But if you move in this particular direction, then you will not be able to reach 3. So basically what you will do is you will move now in the rightward direction. So you'll change your direction and you will take a turn basically. Okay, so one more will be added to your answer. So the total number of times you have taken turn is 4 times. So basically the answer for this will be 4. You can observe this part, like the answer for this particular test case is nothing but 4. Why? Because as you can observe, if I'll tell you again, so let's do it again. So see, suppose that I said that I started from 5. You can start from anything, either 5 or 1. Suppose I started from 5. So if I'm starting from 5, then I will say that, okay, either I can take left or right. That will not be counted as a turn. Okay, the turn will be counted when I'm in motion. So I started initially, so I'll not count it as a turn. Then I was trying to move to the left side, but here I take a turn and I move to the right. So that is one turn I have taken, correct? Then from 1 also I take a turn, right? I take a turn because I was trying to move in this direction. But now what happened? I moved in the opposite direction. So in that case, I will say that I've taken one more turn. After that, if you see, I'm moving in the right. But actually to reach 10, I have to take the path from 3 to 6. So I'm taking a turn in the leftward direction. So one more. So this is the third turn that I've taken, and the fourth turn that I take is to reach this 10. Okay, so basically this is the fourth turn that I take. So the total answer for this case is 4. Let's check it for the second test case as well that has been given. So suppose this test case is only given and we have been given the node 1 and the node 4. Okay, so let's quickly erase this part and see what if we were given node 1 and 4. Okay, suppose we were given node 1 and 4. So in that case, what would have happened? So if we were given the nodes 1 and 4, so we can basically observe that if we are given this node and this node, so see, initially we'll start from 4, and let's say either we can go to the left or right. So suppose we go in this direction, okay, we go in the rightward direction. Then from 2, will I take a turn to reach 1? No, I'll be in the same direction, right? So I'm not taking any turns. So in this case, when I'm not taking any turns, so actually I should have returned 0 if I'm not taking any turns. But you can see in the test case, if no turn is required, right, because you're moving in a straight line, so in that case they are returning a -1. So that means if no turn is required, right, if there are no turns required, then in that case I need to print a -1 for this case. Okay, so what, like, if you will see this diagram, when I have 1 and 4, so what is the relationship between 1 and 4? You can observe that 1 is nothing but the, like, the what is the 1 and what is the relationship between 1 and 4? 1 is nothing but the lowest common ancestor of 1 and 4, right? Because I'll see, like, see, if you, this is one big observation that you can always have, that if you have been given two nodes A and B and you have to find something between them, right? So many of the times you can think of using the lowest common ancestor concept. So I am assuming that for this problem, before doing this problem, you already know the lowest common ancestor. If you don't know, then you can pause the video, you can read about lowest common ancestor, you can revise it and then come back to this. Okay, because lowest common ancestor will be a prerequisite for this. So if you will see, so if I say for 4, 2 is an ancestor and 1 is also an ancestor, right? But what is the lowest common ancestor? For 4 and 1, the common ancestor is only 1 and the lowest ancestor is also 1 only, right? So that is why what will happen, you can see that the number of turns, the number of chances to take, like, see, if you have to just, like, if one of, like, if this is node is A, this node is B. So since A is one of the like, A is one of the nodes and A is the ancestor itself as well, so the number of turns will depend on B, right? So B has not taken any turn, so that's why the answer will be nothing but B only, right? But suppose if that was not the case, and in other case what happened, like, suppose we were given 5 and we were given 10. So what is the lowest common ancestor of 5 and 10? The lowest common ancestor is nothing but 1, this particular node 1. Okay, so 1 is the lowest common ancestor. So what we can try to do is, we can try to divide the problem basically, right? Because if I ask you, suppose that if there's a random question that is asked, right, there's a very popular question that for a particular node A and for a particular node B, what is the distance between the nodes, right? So if you will think randomly, so you'll not get an answer. But if you will think in terms of LCA, so the answer is what? Answer is always the distance, this distance x, right? This distance x, that is the distance between the node A and the lowest common ancestor, and the other distance y, that is the distance between the node, the second node, and the LCA, right? If I find these two distances, then I'll be easily able to return. So similar is the concept here. If I find the number of turns, right, if I find the number of left turns, right, the number of turns in the left part, right, this part, if I find the number of turns here, okay, and I add the number of turns with this part, right, basically suppose this number of turns is x, that I have to take here till LCA, right, till LCA, because they both are meeting in LCA, correct? So number of turns taken here is x and the number of turns taken here is nothing but y. So if I know these turns, then I can optimally get the answer. How? Because if you will see, so let's try and observe how many turns I'll be taking. So see, if I start from 5, so actually I'm not taking any turn currently, but if I'm moving in this direction, so that means I need to take a turn because I need to move towards the right side. If I'm currently moving in the left direction, so now I need to take the turn because I want to reach 1, so I need to take a turn. So I'll move, reach, like, I'll take a turn in the left, like currently in the, like, I was moving in the left, now I'm taking a turn in the right direction, so I'm taking a turn of 1. Okay, so total turn taken in the taken from 2 to 1, path from 5 to 1 is nothing but 1 turn taken, right? So I can simply say that this part, x is equal to 1, like, so basically I've taken 1 turn here, right? Basically I've taken 1 turn in this part. Okay, now if you will observe for this part y, for this segment y, how many turns I have taken. So see, initially if I'm starting, so I'm not taking any turn, so either I can go to the left or right, I don't care. In that case I'll not count it as a turn. So from 10 I reach what? I reach 6. So basically when I reach 6, so my tendency will be to move in the leftward direction only, because currently I was moving in the leftward direction. But if I have to reach 1, so I have to change my direction and I have to move, I should move from 6, I should move to 3. That means I'm taking a turn, right? Because I'm earlier I was moving in the left direction, now I'm moving in the right direction. Okay, because this, suppose this was the left direction, this is the right direction, so I'm changing my direction, so that will be counted as a turn. Okay, so this is the first turn that I'm taking. Then after that, my tendency is to move in this direction, correct? But I am moving where? I'm moving in this particular direction. Okay, if I'm moving in this particular direction, in that case I'll count it as a turn again. So in that case, like I'll count this as a turn again, so the number of turns will actually become 2, one turn here and one turn here. So you will say that okay, the answer should be what, x plus y, right? So x plus y is what, x plus y comes out to be 3. But actually if you remember, so how many turns I was taking? I was taking nothing but 4 turns, correct? Because you, if you will consider, see, I have taken what, I have chosen that okay, what is the left turns that I'm taking, correct? What is the right turns that I'm taking? But there will be one more turn that I'll be taking, right? After reaching the LCA, suppose I started from 5, so I have taken one turn till here, but I'll take one more turn here now. After one, like after one, I'll take one more turn here, because my tendency was what, my tendency was different. My tendency was that I was moving in this direction, but now I have changed my direction, I'm moving in this direction. Okay, so from the LCA also I'm taking a particular turn, right? So that's why at the LCA I'll take a turn, and that will count, that will be counted externally. So x, the number of turns will be nothing but the left turns, like the turns for the node A, the turns that I have take for the node B till the ancestor, plus 1. So the answer would be nothing but x plus y plus 1, you can say, right? But is it actually going to be true in all the cases? Because you have to think for it, right? You have to think, actually is it going to be the case? So suppose if we have been given a different kind of tree, okay, so suppose what we have been given is, we have been given a tree of this kind. Suppose that we have been given something like this. Okay, suppose we have been given something like this. So in this case, if you will observe, so what is the circumstance here, like how many terms do I need to take? So see, if you want to observe here, so suppose that I have A and I have B. So suppose this is node 1, okay, and this is node 3. So for these like from reaching 1 to 3, I have to count the number of turns that I will take. So you can basically observe that if the LCA for A and B, for the nodes A and B, is nothing but A. So what is the number of turns that I will be taking? For X, you can say that the number of turns taken will be 0, correct? Now for Y, like for this part, how much turns will I be taking? So so the number of turns that I'll be taking from B will be what, like if I'm initially starting, so I can either move to the left or right, and if I am not in motion, so that will not be counted as a turn, so I'll move to the left, suppose, right? After that, if my tendency is to move in the left direction only, but I'm taking a turn, right? Because to reach one I have to take a turn, so I'll take a turn in the rightward direction, so I'll count it as one turn. So y will be equal to 1. Now you will say that the answer will be what, x plus y plus 1, correct, according to the observation. So you'll say that the answer would be 2. Actually you will say that okay, 2 turns are taken, but you should think, am I taking 2 turns here? No, I'm not taking 2 turns here, right? You will say that okay, the answer should be x plus y plus 1, but I'm not taking 2 turns here. Why? Because actually when one of the nodes among A and B is the LC itself, then I don't have to take a turn like this. So that is why I can simply return nothing but the x part, the number of turns taken for the first node till till I reach the LC, and the number of turns taken till the from the node B till I reach the LCA. So that will be the answer. I'll not add 1 to it, because if one of the nodes, if either A is the LCA or B is the LCA itself, then in that case I need to say that I'll return x plus y only, right? So this is what we'll be doing, and we'll be doing it recursively. So let's write the code for this problem as well. I'm assuming that you know how to find the LCA for this problem, otherwise the length of this video will be too large. So first of all, I'll write a function for finding the LCA. Okay, so suppose I'm in the main function. So first part will be that how do I find the LCA? So I'll say that okay, I'll first of all find the node star, like let's say LCA. Okay, and for that I can write a recursive function, suppose. So in this function what I'll be writing is, like I'll first of all pass the root. Okay, I'll pass the first node and I'll pass the second node. Okay, I'll pass these two nodes, and after this part is done, so what I will be required to do is, this recursive function will return me the LCA for the current binary tree, right? Node, that is the LCA. So this return type will be node. I'll write the recursive function. So in this I'll pass the root. Okay, I'll pass the root value, like I'll pass the root node, and then apart from this I also need to pass the first the value of the first node and the value of the second node, which are integer values. So int first and int second is what I'll pass. Now after this part is done, so what I will say is, if suppose that the root is equal to null, so I'm again saying that I'm assuming that you know how to find the LCA. This recursive function will help me to find the LCA. So if the root is null, so you know that we will return nothing but a null. Okay, now if like this is the part for LCA, I have not explained LCA here, I'm just writing the code, because if I'll explain, so it will be too large. So I will say that if the root data, right, for finding the LCA, if the root data is equal to the first, okay, or the root data, or the current root data is equal to the second, okay, in that case what we will do is, we will simply return nothing but the root. Okay, after this part is done, so suppose that I do not find the LCA there, so we'll say that okay, the node start, the left subtree, will be nothing but like from the left subtree I'll find the answer, and from the right subtree I'll find the LCA part. So I'll say that okay, recursively I'll call for the roots left, okay, and I'll pass the first value. After that I'll pass the second value, okay. Now what I'll do is I'll say that I'll pass what, I'll pass here node star like right, from the right also I'll try to get this recursive call because it is returning a node. So from the right I'll say that okay, root right comma, I'll pass the first and the second value, okay. After I pass the first and the second value, so if the left is not equal to null, okay, and the right is not equal to null, okay, if from the left that I'm getting else, if I'm from the left I'm getting a node and from the right I'm getting a node, so if both of them are not null, so in that case I'll return the current root, okay, because that will be the answer here. So I'll return the current root, I'll return the current root here, okay. Otherwise suppose that if the left is equal to null, okay, if the left is null, then I will return what, I'll return nothing but the right, okay. And suppose otherwise what will happen if suppose that the like if the right is equal to null, suppose, right. So in that case what will I return, I'll simply return, let's say, the left, okay. If the right is null, then I can directly return the left. After this part is done, so this will be for the calculation of the LCA. Now once I have calculated the LCA, that is the lowest common ancestor for the given like tree, then what I will try to do is I'll try to find the number of turns. So basically I can say that the number of turns I'll find for the node A, right, and I'll also find the, like, initially I'll mark it as 0, and I'll try to find the number of turns for the node B as well, okay. So I'll try to find the number of turns for the node B as well. So I'll initially mark it as 0. After this what I'll do is, let's say I will write a count function, okay. I'll write a count function that will help me to update the number of turns that I am going to take. So what I'll be doing here is, if I have the count, so first of all I'll go to the left part, okay. Like I'll basically go to the left, and what I'll be doing here is, like, first of all, in the, like, for the node A, right, there are two nodes. So for the node A I'll try to find first of all that okay, what is the number of turns, and then for the second node also I'll try to find what is the LCA, okay. So what I'll basically be doing is, I'll simply say that okay, I'll simply say that what I'll be doing is, like, I'll not be moving in the root, I'll be moving towards the left of the LCA. So I'll say that okay, uh, count LCA, and I'll call for the left part, okay. Then I'll pass the first value because I'm going to find the LCA for the first, like I'll pass the second value as well, okay. I'll pass the 0 initially, 0 will indicate something. Then I'll pass the, let's say, the number of turns that I'm going to take, so I can pass it as turns, let's say, okay. And here, like, let's first of all write the function template here so that we can understand it better. So basically what I'll be doing here is, see, what I'll be doing here is I'll be writing a void count function. And why it is not int, because I'm thinking of using an ampersand only, like so that I can update the answer directly without doing int. You can also use int if you want. So what I'll be doing is, suppose that if I have to find, like, in the, basically in the left, like I have to, if this particular tree is there, so what I need to do is, in the left part, like if this particular tree is there, so I, like, towards the left of the LC I want to go, and I want to find X value, and towards the right of the LC I want to go, and I want to find the Y value. So instead of this, I can, let's say that I write it as X and I write this value as Y, okay. So first of all, what I'll be basically doing here is, I'll be simply passing these parts. So what I'll basically do here is, let's say I've written this count function here. So I'll like, first of all I'll pass the node, then I'll pass the first, okay, then I'll pass the second as well, right, second node, first node, and then I'll pass the, let's say, the current direction that I'm at, okay. So I'm assuming that the 0 direction will indicate that I'm in the left, and I'm assuming that when the direction is equal to 1, so it will indicate that I'm going in the right direction currently, okay. Then I'll have a ampersand result as well, okay, that will count the number of turns, okay. After this I'll also have, let's say what I'll have is, I also require like, if I'm moving, right. So if I'm moving, so I'll require the number of turns as well. So let's say initially, like, I'll pass the turns as well here. So as I said, so what I'll be doing here is, see, in the count function, first of all I'm trying to go to the LCA, right. So basically, first of all I'll try to go to the left part of the LCA, correct. So I'll try to go to the left part of the LCA. I'll pass the first node, I'll pass the second node. Okay, initially I'm passing the direction as 0, that means that I'm trying to move in the leftward direction. And apart from this, I'll pass initially the number of turns that I'll be passing will be nothing but 0. Okay, so first of all I'll pass the x value here, because the x value will get updated. So whatever is the x, it will get updated here. Like x will, like one time result will be x, one time result will be y, so they will get updated. And I'll have the number of turns. So initially the number of turns taken will be 0, so that is why I'm passing this here. Okay, then I'll write the count function again, because I'll be going to the right of the LCA as well, right? So basically I will calculate x and y both. So that is why what I'll do is I'll say that LCA of right, like LCA, then I'll go to the, like for this I'll go to the right part. Okay, then I'll pass the first value, then I'll pass the second value here, and after passing first and second I'll pass, like if I'm going in the rightward direction, so I'm passing 1. So 1 will indicate that I'm currently in the rightward direction. Okay, I've started in the rightward direction. Now what I'll do is I'll pass directly y, because y should get updated, and then 0. Okay, so if I'm passing y here, so you can see that y I'm passing by address, so that any change that I do to the result, any updates one by one that I'll do to the result, that will be reflected in the y. Okay, so once I have got this thing, right, suppose that I have got x and y. So what I'll be doing is, if suppose that the, like I have to see this part as well, like there are two conditions as I mentioned. If the LCA data, right, suppose that the LCA data is equal to the first, right, if the LCA is nothing but either the first root, all the LCA data is equal to the second value, right? If the LCA is equal to the first node or the second node, in that case, as I mentioned, the, like if the LCA is different, right, if suppose there are two different, like two nodes, like if like this, okay, suppose you had node like this, and as I mentioned, suppose this is one node, this is one node. So if their LCA will be what, their LCA will be this node. Okay, so in that case you will count the number of turns in this part, like that will be nothing but x, plus the number of directions, number of turns for this node b, that will be y, plus one more turn you will be taking for the LCA, right? So plus 1 you will do. Otherwise, if LCA was the same, right, if LCA was the same, assume that LCA was among one of the nodes only, right? So if you're moving in the left direction, right direction, one by one, suppose. So in this case, let's try and write this. Suppose you are moving one time left, one time right, and stuff like this. Okay, so in this case, suppose that this node is a, this node is b, suppose, right? So in this case the LCA of a and b is the same, that is a. So in that case, you, after the LCA, you don't have to take any terms, so that's why you'll return nothing but x plus y only, right? So what I'll be doing here is, I'll simply say that if it happens that LCA data is equal to either of the nodes, in that case I'll simply return nothing but x plus y, as I mentioned already. Otherwise what I will do is, otherwise I can return nothing but x plus y plus 1. So this is what I'm doing in this function. Now we need to implement the counting the turns function. Okay, so basically this turn function we need to implement. So how will we write it? So see, the base case will be that if the root is equal to null, okay, if the root is null, then we can simply return from here. Okay, will there be any other base case as well? You can assume that there will be other base cases, like there will be other case as well. So suppose if it happens, right, if it happens that I am trying to count, so what will be the case? So suppose that if this was the LCA, right, so suppose I'm trying this particular tree again. Okay, suppose what was happening was, this was the LC that I have already found. Okay, so I'm moving in the left direction, like I started from here, and this was the node A. Okay, so suppose what happened was, somehow I moved here and I have updated the count of turns also. So if I reach, like suppose that below this also there were several nodes here and there, but if I have reached this particular node A, right, if I have reached the node with the first value, okay, so in that case I'll simply return from here. Now whatever answer I have stored, I will update it and I'll simply return from here, correct? And similarly, if there is a node B here, suppose, right, so if I'm moving down, like suppose below this also there were several nodes, but if I have reached this particular node, so whatever number of turns I've taken in this direction, that also I'll update simply in the result and I'll return from here, right, because I'll not be required to go down. So basically what I'll be doing is, if it happens that suppose that the root data, right, if the root data is equal to the first, right, if it's equal to the first, or the root data is equal to the second node. So if I have reached the first or the second node, right, because I'm trying to move from the LCA, right, I'm coming, like basically I'm moving to the node A from the LCA, right, and similarly I'm moving to the node B from the LCA itself, right. So that's how I'm going to count the number of turns. So if the root data is equal to the first, right, if it's equal to the first, or if it's equal to the second, in that case whatever I have calculated up till now, the number of turns, I'll simply store the number of turns in the answer, and I'll return from this function, right? I'll update my resultant answer, and like resultant, that will either result will either be x or y, depending on the first call or the second call, right? After this part is done, so what I'll be doing further is I'll simply say that if that is not so, I'll check in which direction I'm moving. So if suppose my direction was equal to 0, so this direction 0, I'm saying when I'm suppose that moving towards the left direction. So if I'm moving in the left direction, okay, so if I'm moving in the left direction, so I can either go to the left or the right direction, correct? So suppose that what happens, I suppose that I go from this current route that I'm current node that I'm at. If I go to the left only again, right, if I go to the left again, so in that case what will happen, will I, if I'm going to the left only, right, suppose that I started from the LC, right, and I move to the left direction, okay, then again if I'm going to the left direction, so am I taking any turns, am I updating any turns? No. If the direction remains the same, if I was moving towards the left side and I'm moving to the left again, so in that case the direction will not get updated now. So in that case what I'll say is, I'll say that okay, the second will be passed, and the direction will remain the same, that is left, 0 will indicate the left, and I'll pass the current result, and the number of turns that I'm taking will remain the same, right? Otherwise, suppose if that is not so, if I'm moving to the right side, if the current direction indicates 0, that means a left, and I'm currently moving to the right, okay, I'm currently moving to the right, okay. So suppose what happens, suppose I was at like suppose I started from the LC or a particular node, suppose I started from here, I was trying to move in the left direction, but now I have to move in the right direction, okay. If I move in the right direction, so I'm taking one turn, so that's why I'll update my turn with 1, right? So I'll add 1 to my turn. Okay, so what I'll pass here is, I'll pass the first, I'll pass the second part here as well, I'll pass 1 because I'm moving to the right direction, so I'll update the current direction. I'll pass the result here as well, and then after this part is done, so I'll say that I'll update the number of turns as well, so number of turns plus 1, right, because I'm moving in the rightward direction. And similarly I need to say that if that is not so, so if it is the else part that I'm going to write, so in the else part what I can say is, I'll again implement this count function, okay. Suppose else, what does else means? Else means that else basically indicates me that the direction is equal to 1. So if the direction is 1, so that means I'm currently in the rightward motion, okay. So if I'm currently in the rightward direction, so suppose that I'm moving, okay, suppose I'm moving, and currently I am moving in the rightward direction, okay. If I'm moving in the rightward direction, so from right, if I go to the left, okay, suppose I was moving in the right, if I go to the left as well, so I'm saying that if I'm currently moving in the right direction, okay, and from direction, okay, and from there I these conditions, then if I'm moving to the left, so I'll change the direction to 0, that means the left, and I'll pass the result as well, okay. If I'm moving to the left, so I'll be taking one turn, because currently I was moving in the right direction, and now I've started to move in the left, so that means I'm taking a turn, so that's why turn will get added with 1, okay. Otherwise what can happen, suppose that if this was the node, right, this was the scenario, although the tree can be big, I'm just showing a smaller case. So if I was moving in the right direction only, right, and then from here also I move to the right, so there is no turn taken, so I'll not update the turn, so I'll simply say that I'll move to the right of the node, okay. And here what I will be doing is, I'll be passing the first, and I'll pass the second, and I'll pass the like that direction as 1, and I'll pass the result, and I'll pass the turns, because the turns will not get updated here. Let us try and compile this code to see if there is any error in this code or not. That was for the sample test case. Let's try and submit it and see if it works all the cases, or we need to do something else. Okay, so you can see that our solution was able to pass on the very first go. It was able to pass all the test cases that are there, 203 test cases. And now talking about the time complexity and the space complexity for this code. So if you see, so what are we doing? First of all, we are finding the LCA, and that we are finding very optimally, right, because we are just iterating through all the nodes, and then we are finding the LCA. So that's very fast. Okay, that's a kind of order of n. So what is the time complexity overall? See, what we are doing is, like, if you see, the count function is running, right, like basically we are iterating through each and every node exactly once, so that will, like, we are simply traversing the tree with the help of, you can say, DFS approach, so that the time complexity will be order of n, and the space complexity will also be there, and the space complexity will be nothing but the recursive stack space, so at most it will be nothing but order order of log n, that is the order of height of the tree. And in the worst case, if the tree is like this, if the tree is skewed in nature, suppose, right, so in that case it will be order of n in the worst case. That will be nothing but the recursive stack space. So in case if you understood this problem, so make sure to hit the like button, comment on understood as well. And I'm saying again, if you don't know how to implement LCA or how to find, if you don't know how to implement LCA or how to find LCA in a binary tree, so make sure to learn it. If you learn it, then this problem becomes a cakewalk. Thank you for watching this video. In case if you have any queries, so you can write that in the comments.